Welcome back everyone on ConveyorU. Once again with a little bit of delay, considering the kind of pressing issues that we have these days. It's been very difficult for me to keep up with the pace. But anyway, this first video after COVID-19, it's not over yet, but let's anyway say that it's a little bit more relaxed now, is about last in first out buffering systems, and particularly about Pater Noster last in first out buffering system. I chose to begin from this one, even if it's not one of our favorite, because it's the oldest, possibly one of the oldest buffering system that we have out there in the market. Many companies do this kind of stuff, and it's not so popular anymore. We'll get into the details of why it's not so popular anymore, but also why it could be a good choice in some situation anyway. So, first of all, what is a Pater Noster buffering system? I will try to help myself with some pictures. So, the Pater Noster buffering system is basically this bad boy over here, or maybe this other one. It's plain and simple a step-by-step elevator that can bring one or more product, usually more, up from the delivering conveyor. Okay. The basic configuration, the most simple one, it's just a step-by-step elevator that works on both sides of the normal conveyor, and through pneumatic devices you will stop the products in front of the layer, create the layer, go up, bringing up a number of products, and then bringing them back down when you need to go back to normal production. Okay, so the most simple configuration is this one. So one straight conveyor that passes through, and some pneumatic devices. It's very simple, of course, but it has its limitations. First of all, it's not a very fast machine. It's a little bit slow because there is a lot of pneumatics and a lot of movement involved when you need to have the full cycle to go buffering. And secondly, it has the main issue. It's not an issue, but it's a limit. That the product that you will handle inside the Pater Noster buffering system will need to be capable of accumulation, so the possibility to push one against the other. That is the main limit that you will face in front of this kind of buffering system. The other point could be that if you have a lot of changeover in the formats, particularly from the point of view of the width of the product coming on the conveyors, the Pater Noster will begin to get a little bit more complicated mechanically wise, because we will need some kind of adjustment system for the two opposite layers of the step-by-step elevators. Okay, I will try to explain myself now with some pictures and some videos about the working principle of the Pater Noster buffering system, in order to get a little bit more into the details, the mechanicals, and so on. So let's try to get a little bit more deep in how a Pater Noster is made and what are his strength points and his limitations. Okay, let's see. Okay, so let's use this picture as an example of the most basic configuration of a Pater Noster buffer. This one is one of the oldest application we made, and we wouldn't do this in this exact way nowadays, even if it's probably the most economical one. So if the occasion calls for it, it may come back and be useful. But we will see then what would be the configuration we would suggest to the customers these days. So let's just make some annotations here and see what we are talking about. Okay, so let's say that here we have just one conveyor passing through. So in this case the products are packaged white paper for printing devices, and the conveyor simply passes through the buffer, and this over here is of course the structure of the buffer. Okay, now take this away. The product passes through, and there is a let's say simply a pneumatic stop on the exit side, and when the layer is ready on the conveyor, the buffer will go one level up this way. So these two are the chains that brings around the clamps, and that brings up the product. So let's take a little bit of a zoom here, and we will see these are the clamps that bring the products up. So we prepare a layer with a pneumatic stop, and then we simply go up, bringing up the number of products, which is depending on the size and the length of the buffer, how many products we can bring up. This is the basic working principle, and this is the most simple configuration. Of course, if we want to handle a little bit the speeds of the feed and the outfeed of the buffer, it could be a good idea to complicate things a little bit. So let's go and see how we do it. Okay, so here we are again. Let's move this on the side. This is how is the side view of how we would propose a Pater Noster buffering system today. We will have one inlet conveyor, one other conveyor. This is the buffer itself. Inside here, let's draw it in blue. Even if we don't see it, we would have another conveyor, which is the buffering conveyor. And then we have an outfeed conveyor. Okay. The reason why we split the conveyors in 3 motors is actually pretty simple. This would help a lot in handling the trains and the accumulation pressures and the in-feed and out-feed of the buffer during the cycle. So the most typical situation, the working cycle, we will explain it looking from above. So let's close this and let's go from the top view. Okay, here we are in the top view. Once again, remember this is the inlet, outlet, buffer, and inside here we have the buffer conveyor. Okay, now let's clear this for a moment so we are not overcrowded with too many lines. The typical working cycle is that products would just pass simply through all the conveyor without stopping, okay? If everything is going good downstream. So we would not have any action through the buffer. This is the normal direction flow and nothing happens, okay? Let's go and see what happens if we have a downstream stop, okay? So let's take this product away. And we will be marking in green the pneumatic devices, okay? So if something downstream stops, one pneumatic stop will go, one pneumatic device will come down at the end of the buffer conveyor, and the product will begin to accumulate on the buffer conveyor, okay, and until we have enough boxes or trays to complete a layer, okay. So all these are boxes in accumulation. When we have enough boxes, the boxes are ready to go up, but we need to relieve the pressure from the boxes that are still coming from the line. What we will do in this case is that we will have another pneumatic stop, possibly a tampon, a pusher from the side, that will block the first box of the that is outside of the layer, and so keep the pressure there. And this pneumatic stop will move back a little bit to relieve the pressure of this layer, and the whole layer will go up one level. Then this pneumatic stop here is released, and the product will fill once again the layer in front of the stop, and the cycle goes back once again, okay. When we do this, of course, we have immediately the idea of why we need actually to have the product that are capable of accumulating, of course. But the other thing that we need to point out is that when we do the outfeed of the buffer, we will work in a pretty similar way, and we will go through this video and make another case, which is the unloading cycle of the buffer, okay. So let's cancel everything, okay. And let's go back to the normal production, okay. I will leave the pneumatic stops there just to give an idea. So the downstream machine will start back to cycle and begin to work, okay. So downstream we are going back to work, and we can have boxes that passes through the buffer and just go straight to the downstream machine. But we want to have the possibility to give back some layers each minute during normal production. So in this case, the working cycle will be exactly the opposite. So we have boxes running on the line, okay. And we want to feed back one layer. So what we will do is that this pneumatic stop over here will block the arriving boxes that will begin to accumulate on the inlet conveyor, okay. And this will happen for enough time for the boxes that are on the buffering conveyor to get out and go outside. Then the buffer will come down one layer, and so the buffer will deposit one layer of boxes here, and the buffering conveyor will move extremely fast to evacuate this layer in order to then remove the pneumatic stop and let the normal production go back. Now, if you understand that it's this configuration means that we will have a long train of product, a long batch of product going to the downstream machine. So we will need to take care of this, and we will explain this in the closing of the video. But remember when we discussed product arriving batches in the first series of ConveyorU, so it's important to take care of this situation. Okay, so this is for what is the working principle. Okay, for loading and unloading, and the unloading will go on until all the layers are clear, if the machine downstream does not break down again. Okay, so this is a pretty simple working principle. The only thing that we could add, but we could say, let's go to look at some pictures to give some details about what happens when we need to adjust the sizes of the boxes coming in. Okay, so let's see what happens when we need to adjust the size of the products coming in, and we have different variation of the sizes. Okay, so the only thing we really need to take care about is the width, so from here to here. Okay, because the length is going to be taken care simply with adjusting the length, the number of product that goes on the layer by maybe adjusting the position of the pneumatic stop. But the width need to be considered specially, because of course we need to have the exact distance between the clamps that bring up the product. So as you can see here, let's move this up, we have this knob to adjust the position, and this whole part will move on the left or the right according to the size of the box, using this handle. Okay, so let's see how this is made. As you see, this is a manual adjustment. There are some angular joints, and let's go to another picture. You see here how the adjustment works. So we have an endless screw here, and once again here we have the movement on the back or on the left or the right of one of the column of clamps. In this case we had an application where this side was fixed and only this side was moving back and forth. It may happen that both sides need to move and we have a fixed center and not a fixed side, so in that case the machine will be a little bit more complicated, but conceptually there is not such a big difference. One consideration I would like to make is also about the adjustment of the height of the product, and this is really not something that is handled as a format changeover. We will simply need to design the machine in order that the height from one clamp to the other is enough to take care of all sizes of boxes. Of course, this has an impact in case of many different sizes of boxes, because we could have on the same height of buffer the possibility to accumulate more with smaller, not so tall boxes. But if we have a bigger format, our buffering space is going to be limited by the bigger format, and is going to impact also on the smaller one. So something that we need to remember. Okay. So coming back to wrap this video up, we saw typical configuration of the Pater Noster buffering system, at least what we would propose as a modern kind of Pater Noster buffering system. We saw his limits, and one final warning that I would like to give to everybody who is selecting this kind of buffer is always remember that products will get back into production from a buffering system like this in trains. So remember when we discussed in the basic ConveyorU training the difference of handling product evenly paced or in trains, in batches of production. So this is what this kind of machine will do. We will give back products in batches. So the downstream machine will receive trains of product, batches of product, and these machines must be capable of handling this kind of situation. Now, normally, considering that the Pater Noster is handling a product that can accumulate, this is not a big issue, because anyway you will be always able to, let's say, phase back the product, even if the downstream machine need to receive the product evenly paced, because you just need an accumulation conveyor to put them all together in a row, and then a phasing unit, a phasing conveyor that accelerates them a little bit. But this requires space. So this is the main issue that you will need to take into consideration when you need to work out a Pater Noster buffering system. You will not be able, however well designed the in and out system will not be able to have evenly paced products outside of the buffer unless you put a specific system to make this configuration when you come out. So just remember this, it's very important, and we will see how with other kind of buffering this problem may or may not present itself, but anyway in a much more limited way compared to the Pater Noster. Okay, so this is it for what concerns Pater Noster last in first out buffering system. On the next episode we'll talk about spiral buffering system for last in first out configuration, and I will be waiting for you guys, so see you soon. Thanks for listening to ConveyorU.